right, this is Algebra 2, Lesson 51. We are on page 221. We finally get to imaginary numbers. Okay.
This is where we just guess.
No.
Just guess.
What is the square root of 4?
2.
More.
Sorry, my bad. Whoops.
It's not.
Oh.
What?
Yeah.
Why?
It's why? Because
I hate imagining.
isn't this
Oh yeah, that's true. No.
and isn't this
We know you're right.
Don't need to rub it in. Don't need
right? Okay, what is this?
Plus.
Don't put that one in.
Oh no, it could be either.
Plus minus.
No, it can't be either.
What?
No, they're options.
4.
It's 4.
Ah!
Oh, I thought it
I
was
was right
minus.
this time.
Never mind.
Okay, what is this?
-4. 4.
That's correct.
Don't you are smart.
Okay, but now here is the question.
Here's the
To be
kicker.
or not to be?
What do I do with that?
Oh.
I.
There's nothing I can multiply.
I.
I.
So I have to divide this into,
Insufficient information.
I have to make it into something that makes more sense.
So would it just be?
Okay. This is where the idea of complex numbers comes in. Complex numbers. So in the complex numbering system, we have real numbers, which are irrational, rational, integers, whole numbers, counting, okay? That's the real side. Anytime you hear the word complex, even though reals are part of the complex numbering system, anytime you hear the word complex numbers, you should always think imaginary.
Fake.
Correct. There's only one of them. There's only one complex number, and it's written I.
How is that even a number?
Well,
It's not.
it is. It is so we can look at the negative radicals. It's used a lot in the polar system, which, like if I were to graph you a polar graph, it would look like this. Mostly. It might look like something like this. It could look like a flower, actually. I guess it would start here. It would start here. And I'm struggling doing this. Okay, anyway, you get the idea. We look like a flower. Such that we have an x-axis and then we have the y-axis. That's eventually where we will go. But this is called a cardioid.
Oh, it's kind of like a heart. Like
Right, yes. All right.
that way.
So the only reason we have the imaginary system is because we can now look at radicals that have even roots that have a negative under them. All right. So I is equal to the square root of -1. That's what it equals. All right. So if we were back here, this would be I. And what's the square root of 4?
2.
So what does the square root of -4 equal? 2i. Okay, so,
Somebody said that earlier.
Yeah.
Yeah, said that.
okay. I is in your calculator.
Where? Oh yeah, I see it. How do I get to
Can
it?
everybody make sure that your I works? You have to have
Shift
it.
I. Shift I.
You have to have it in the complex.
But
So everybody do the square root of negative 4 in your calculator.
it's two. Two.
Okay. Mode. I'm in the wrong.
Mode complex.
Mode 2. Now do the square root of negative 4. Do you get 2i? If you don't, then do mode 2.
Wait, how
Oh
do
yeah, I got it.
You got it? Mode is the top left button. I'm sorry, shift.
Well, no,
No,
mode.
it's mode.
No, it's mode. It's mode. On the right hand side, right next to the on button. Does everybody see that? Does everybody get 2i in your calculators? Everybody's got it? Everybody's calculator is set?
Yes, ma'am.
Okay. All right, so I want y'all to look at this.
2.
Okay, we're going to talk about patterns. Okay, is everybody watching? Like you really need to watch. So I squared is the square root of negative 1 times the square root of negative 1. What's the square root of negative 1 times the square root of negative 1?
I don't even want to guess.
It's negative 1. It's negative 1.
But that's not imaginary.
It's not.
Why?
Why are we just
Okay,
going
let's
into
look. Let's look.
Stay away.
What about I cubed?
Negative 1 times negative. Square root of negative 1 times square root of negative 1.
Wouldn't it be negative 1
So I equals.
Okay, what is this?
Negative 1.
This is negative 1. What is this?
Square root of negative 1.
Which is
One
I.
That.
So is that negative I?
This ain't right.
eye. Is pi a real number or a random number?
This is not relevant.
Pi is real.
Can you explain why we need this? Because it might make more sense if we know like the application instead of just going
You
around.
you need to know the patterns.
Okay.
Okay?
Okay.
All right, do you see this so far? Do you agree? Okay, so everybody look. So far we have I square root of negative 1. I squared is negative 1. You agree? I cubed is negative I. We get together so far?
What about added the 4th?
We're going to add the 4th. So I to the 4th is the square root of negative 1, square root of negative 1, square root of negative 1, square root of negative 1. What's that?
Negative 1.
What's that?
Negative 1.
Oh, that's just 1. So it's just I.
No,
No, it's just
Just
1.
here.
I to the 4th equals I.
it's just 1.
Oh, it's just 1.
It's just 1. Okay, we're going to go one more. We're going to go I to the 5th. Okay? So I'm going to erase this. Make that a 5th. And add a square root of negative 1. All right, we said this is negative 1. This is negative 1. What is this?
Square root.
Square root of negative 1 is what?
I.
I. Okay, what's negative 1 times negative 1?
1.
Times I.
I.
I. So I to the 5th is I.
What?
Look,
Okay.
But I to the 4th is just 1.
Wait.
okay.
I didn't.
I understand.
So
but
everybody
don't get me
look.
wrong, I do
Everybody
understand.
look. We've got a pattern. Okay, I'm going to teach you my Miss Haleyism. You ready? I won, the middle two are negative. I won, the middle two are negative. I'm just telling you, I'm tutoring a college algebra kid and he remembered this. I won, the middle two are negative. I is I. I squared is negative 1. I cubed is negative I. I to the fourth is 1. I to the fifth is I. I to the sixth, I to the seventh, I to the eighth, I to the ninth, 10th, 11th, 12th. The pattern repeats it.
Can you say it one more time?
I won, the middle two are negative. I won, the middle two are negative. I won, the middle two are negative. I won. Yes! Okay? It's a pattern. All right, so I'm going to teach pattern first, and then we'll go into the rest of this lesson.
That's much.
All right, there are a lot of patterns in life. What if I said, what is I to the 37th? What is I to the 37th? Could we figure it out?
What's
We could.
I?
Calculator.
It's I, because it's odd.
It's math error.
Correct. It's math error. It won't go that high. Okay, so everybody look. I'm going to show you. You need to know how to do this and not use your calculators. Everybody paying attention. How many values are in the pattern? 4. So it goes through 4, then 8, then 12, then 16. Okay, you get it? Okay, so listen. Are you watching? I'm going to take 37 and divide it by how many are in the pattern. Because every 4 times it goes through the entire pattern. And then I'm going to look at the remainder. The remainder is going to tell me which one it is. How many times is 4 going to 37?
9.
9 times 4 is?
36.
My remainder is 1. That's what I'm going to look at. Here's your remainder.
Yeah, it's I.
If I have a remainder of 1, it's I. If I have a remainder of 2, it's negative 1. If I have a remainder of 3, it's negative I. If I have a remainder of 0, it's 1. Because that means it goes in 4 an even number of times. All right, so what if I said I to the 111th? Can y'all figure it out? Figure out what it equals. I just made that up.
What even goes
Wait,
to
so I to the
11?
37 equals I?
It equals I. What does I to the 111th equal?
Okay. Is it possible to do this in the calculator?
No, because you need to know the remainder, not a decimal. Got it? Do not work this in your calculator. What does it equal?
Negative I.
Negative I. Everybody get that? Okay, so I did 111 divided by 4. Why 4, everybody?
Oh wait, because of the.
Because the pattern. There are 4 terms in the pattern. I'm looking at the remainder. When the remainder is, this tells me where it falls in the sequence. I'm going to show you 2 other patterns that are not in your textbook.
Can you do another one?
Sure. Let's do I to the 301. There we go. I'm just picking random numbers. Yes. Don't use your calculator.
I'm not using my calculator. I just want to know like how will we need to type I into our calculator at some point? Because I can't seem to be able to.
Yes. Yes.
It's right there. It's purple. I don't know how to
It
do
is.
You see the hand.
Pretty sure Daddy was knocking me down. Pick it up for me.
Maybe. What time is it?
Time for you to get a watch.
No shift, no nothing.
Is it right? Yeah.
All right, what did everybody get?
I
Did everybody get I?
got A actually.
My.
I got pi.
Did everybody get I?
Why?
Okay. All right, stay with me, ladies and gentlemen. I'm going to show you two other patterns that are not in your textbook. Okay. It's the same concept. What if I have repeat decimals and I want to know what is the decimal? I actually wrote this down. What is the 57th decimal place? Like, I just want to know, what's the 57th decimal place? Okay. Why do you think I'm teaching you this? I've seen this on the ACT. It's the same concept. All right, how many are in the pattern?
3.
What am I going to divide by?
3.
3, okay?
18 times.
When my remainder is 1, the digit is going to be a 1.
Or is the digit gonna be a 1 or is
The
it?
digit is going to, I should have changed these. Okay, let's just
Yeah.
change it. 5, 6, 7. We'll do 5, 6, 7 repeat.
So
Got
when
it?
the remainder's
When the
1,
remainder's 1,
it's gonna be 5.
it's going to be 5. When the remainder is 2, it's going to be 6. When the remainder is 0, because that means we've gone through it an even number of times, it's going to be 7. Got it? So I take 57 divided by how many repeat
3.
digits I have? 3.
Nine. So it's 7.
7. Does that make sense?
That's pretty cool.
Okay. I'm going to do one more. What if I have 2 to the x, okay? And I want to know what is the digit in the ones place, in the ones, O-N-E-S, I can't write, in the ones place. What is the digit in the ones place for 2 to the 77th? Okay. Your calculator's not going to do that. All right, but we can do it. Okay, let's just look at the pattern. 2 to the first is 2 squared is
4.
2 cubed is 2 to the fourth is 2 to the fifth is
32.
same one's place. 2 to the sixth is,
4.
I'm repeating the ones place.
Oh my gosh.
Okay, so how many digits do I have in the ones place?
4.
4. So what am I going to do?
Divide 77 by 4.
I'm going to divide 77 by 4. If my remainder is 1, what's the ones digit?
2.
2. If my remainder is 2, what's the ones digit?
4.
3.
8.
8.
0.
16.
6. Just the ones digit. Got it? So you take 77 divided by 4. What is that? 9, 36, 1. What's the one in the, what's the digit?
2.
2. Do you understand that? Both of these questions have been on the ACT. If you recognize patterns, you figure out that they didn't tell you that this was a pattern question. But when you look at it, you could say, there's got to be a pattern. I've got to look at it.
Can you do it as a second place?
No, has to be only the ones. The ones is what repeats.
I thought there were patterns.
There are in the units position. Yes. Okay. Patterns. Patterns repeat, right? The same way with I won, the middle two are negative. I won, the middle two are negative. Okay, you'll remember that for the rest of your lives probably.
Somehow, just because you said it. Maybe
It's-
you should read us our recitation.
Okay, so let's walk through the examples in the textbook. Page 223. Let's start with 1. What's the square root of 3 times the square root of 2?
Square root of 5. Or
Square root of
6.
6, exactly. What is the square root of 3 times the square root of negative 2?
Square root of negative 6.
Which is what?
Square root of 1, or it's square root of 6 times square root of 1. Negative 1.
Which is what?
6i. Square root of 6i.
Okay, everybody look on the board. When I is written with a root, the I goes out front so that it doesn't appear to be under the radical. Got it? Always. In every textbook I've ever looked at. All right. What is the square root of negative 3 times the square root of negative 2? Let's do it using I. What is this using I? Square root of 3i. I square root of 3. What is this using I? I square root of 2. What's I times I?
I squared. Negative 1.
You cannot multiply two different negatives underneath because what do you get?
Positive.
A positive. This does not equal the square root of 6. You have to pull out the I first. Does that make sense? Do you see how this is different than what you would think? Yes? Does everybody grasp that? All right, so what is the square root of negative 13 equal? Landry, what is the square root of negative 13 equal? Nope, don't use calculator. Just tell me.
Just I-13.
I square root 13. Got it? Got it? All right. What is square root of negative 12? Elliot?
I squared root of 12.
Can you simplify that?
That would be 2i squared root of 3.
Correct. Everybody got it? All right. So let's look at 51.3. Okay, what if I already have i's? You treat i's just like you would treat x's and you would treat radicals. If I had 3 square root of 2 plus 6 square root of 2, what would I do?
9 squared root of 2.
Add the coefficients. If I had 6x minus 3x, what would you do? Subtract the coefficients. When you have i's, you're adding or subtracting what is in the coefficient position. I doesn't change. Does that make sense? Reals go first, complexes second. So we add our reals. 4 minus 2 is 2. 6 plus 3 is 9. Got it? You add your reals, you add your complex parts. Make sense? Everybody with me? Okay. Look at example 4 on the top of page 224. what would be the first step that I would do in this expression to simplify it? Eliminate parentheses. All right, so this first part is 4 minus 3i. The plus doesn't change any of the signs inside the parentheses. But this negative changes the signs of the terms on the inside of the parentheses. Got it? I add my real. 4 plus 6 is
10.
minus 2.
8.
8. That's my real part. Real always goes first. Then negative 3i minus 4i is
7i.
negative 7i plus 5i.
Negative 2i.
That's the final simplification. Make sense so far? Those are the easiest ones. All right, example 5. Okay. This is the same as 2i squared. What's I squared?
Negative 1.
So this is 2 times negative 1. It's a negative 2, yes. This is I cubed. What's I cubed?
Negative
Make sense so far? Plus 2i minus 4 minus, what's the square root of negative 4? I
Square root of I2.
2i. Does that make sense? The square root of negative 4 is the same as the square root of negative 1 times the square root of 4. This is I, and that's 2, but we would write the 2 out front. Make sense? All right, now this is negative 2 plus 3i plus 2i minus 4 minus 2i. Let's add our reals first. Negative 2 and negative 4.
Negative 6.
3i plus 2i
5i.
minus 2i.
3i.
Final answer. Okay,
You
this
have
is
to write them like with the 3i first.
never with the 3i. Complex is second. Real, complex. It goes rational, irrational, rational, irrational, complex. That's the proper format for all numbers, okay? All right, let's do 51.6. Are y'all getting this? I feel like y'all are getting this. All right.
Miss Amy,
Uh-huh.
can you fill my line?
In just a minute. Okay. All right. You can imagine I'm probably going to ask you something like, what is I to the 94th? You can imagine I'm going to ask you that on a test. Surely I would. Huh?
Imagine.
Yes. Imagine. Yes. Okay. What is I cubed?
Negative I.
Negative I. Okay. Are you saying in yourself, in your brain, I won, I won, I won, I. Okay, look. I won, I won. The middle two are negative.
No, I get it.
Okay, like seriously. Kid taking his final for college algebra, that's the first thing he's writing on his test. Because imaginary numbers are on his test. I won, the middle two are negative. How did he remember that? I taught him. Crazy. But you will remember it, right? Okay, so it's I won, it's in the middle two, so it's negative. You got it? All right, 2 is, I squared is I won, but it's negative because it's in the middle. Are you following me?
2 negative, so negative 2.
So plus 2 times negative 1. This is just 7i, because I is I, plus 4, plus 2. Okay, this is I1, I. So that's just I. Right? It's 1, 2, 3, 4, 5. Make sense? All right, so this is negative 3i minus 2 plus 7i plus 4 plus 2i. We add our reals, negative 2 and 4.
6i. Oh, sorry. 2.
2. Negative 3i plus 7i.
6i.
Negative 3 plus
4i.
7i is 4i plus 2i is 6i.